Hello students, this video is about a very important phenomena that happen around us in many ways, and that is called total internal reflection. So we are going to study about TIR or total internal reflection in this video. For this we have to move to the diagram here. So whenever we have an object placed in a denser medium, as shown in the diagram, we have a combination of two media. One is rare and the other one is optically denser in comparison to that. For example, air and water. This is the interface. This line is showing the interface between the two media. And if we take the example of air and water, then we can say that this is the air water interface, or any other medium can also work, but their optical density should be different. There are two different media and object is placed in the denser medium. That's what we are studying. So whenever object is placed in a denser medium, there are many possibilities of light rays coming from that object. So if the light rays coming from the object are normal to this interface, means the light that is incident on the interface is along the normal, then it will pass in the same manner, means there will be no banding of light ray. They will follow the same path on which the rays are coming. However, if they are making some angle, suppose angle of incidence is I, that these light ray make with the normal, then since these light rays are passing from denser to rarer medium, so these light ray will bend away from the normal, means actually their path was like this, but they bend away from the normal. But if we increase the value of incident angle, means if the light rays are incident or at some more angle, then we get a certain angle at which this light ray go along the interface, or the angle of refraction becomes 90 degree for that angle of incidence. Means जैसे जैसे we are increasing the angle of incidence, angle of refraction will also increase, and we get a point where angle of incidence has a value such that for which we get angle of refraction is equal to 90 degree, and the ray will pass along the air water interface or along the interface between the two media. This incident angle is known as critical angle, and we denote this angle as IC. So this angle for which we get angle of refraction is equal to 90 degree, that is called critical angle, and all the angles below IC, all the values of angle of incidence below critical angle, we get refraction. Means there is some angle of refraction which will vary between 0 and 90 according to the laws of refraction. Now what if we increase the value of angle of incidence further? अगर हम I का वैल्यू क्रिटिकल एंगल से भी इंक्रीज करते हैं, देन आफ्टर दिस पॉइंट द रे विल गेट बैक टू द सेम मीडियम, because as we are increasing I, angle of refraction is also increasing. So if we increase the value of I, we get the rays bouncing back to the same medium. Now the process is of refraction, but the results that we are getting are of reflection. Okay, so this is a reflected ray. This is a totally reflected ray, and the reason is that although we were expecting refraction there, but the angle of incidence is such that, or the value of angle of incidence is greater than critical angle, so for that we get angle of refraction more than 90 degree, or here the significance of refraction ends and we start treating it like a reflection, because light rays are coming back to the same medium, and this phenomena is called total internal reflection. So when light rays passes from denser to rarer medium, or when object is placed in a denser medium, or we can say when light rays are passing from denser to rarer medium, then at the interface there is a certain angle more than critical angle, or there is a certain angle at which we get the rays totally reflected back to the same medium. Then this phenomena is called total internal reflection. So we can explain this phenomena as, first, the ray that is coming normally to the interface pass on to the other medium undeviated, right? That means I am talking about this ray which is coming normally to the interface. It will go in the same direction in the other medium also. It won't show any kind of bending. Now to explain the phenomena, I am assuming this as ray 1, this as ray 2, and this as ray 3. So for the ray 1, if the ray is incident at a small angle, if the ray is incident at some small angle I, then after passing the interface, since it is passing from denser medium to rare medium, that's why it bends away from the normal and shows a refraction. So after passing the interface, it bends away from the normal, as shown for the ray 1. This is the ray is coming at angle I, this is the angle of incidence, and it passes from one medium to other such that it bends away from the normal, and the angle of refraction is r. Now angle of refraction is greater than angle of incidence. For this case, angle of incidence is small and angle of refraction is more. This we have to note. Second thing that we have to note is, as we increase angle of incidence, angle of refraction will also increase. So as we increase the angle of incidence, the ray will bend more and more while passing from one medium to another, and it will be away from the normal, so we get more angle of refraction. These are the 2 points that we have to consider. Now coming to ray number 2, for ray 2, when we were increasing the angle of incidence, we get a certain angle of incidence for which angle of refraction become 90 degree. So at some angle of incidence in the denser medium, so I can write it as at some angle of incidence in denser medium, we get r, or angle of refraction, is equal to 90 degree in a rarer medium. Now this situation come when the angle of incidence is equal to the critical angle, or the angle of incidence at which we get r is equal to 90 degree, we call that angle of incidence as critical angle for that interface, critical angle for that combination of media, and it is denoted by IC. So as we increase I, R will be increasing, and at a certain value of I, we get R is equal to 90 degree, and that value of I is called critical angle for that particular combination of media. For every combination it will change, its value will change, and for a certain combination it will remain same. So if we have 3 setups and the medium is same, air water, air water, air water in all the 3, then we will get critical angle same for all the 3 cases. But if the combination is glass water or air glass, then in such case critical angle will vary. So now moving to the third ray. Now we further increase the value of angle of incidence. अगर हमने IC से ज़्यादा और increase किया I का value, then these rays will again bend away from the normal, and ultimately they will come back to the same medium. Means if angle of incidence I is increased beyond IC, in that case no ray will be refracted, but they come back to the, or they get reflected back to the denser medium. Right? So such situation in which rays are coming back to the denser medium with instead of undergoing refraction, that ray is called totally reflected ray, and the phenomena is called total internal reflection or TIR. So now we can define TIR as the phenomena in which it is the phenomena in which a ray of light traveling at an angle of incidence now that angle of incidence should be greater than critical angle. So traveling at an angle of incidence greater than critical angle and it should be passing from denser to rarer medium, right? So the phenomena in which ray of light which is traveling at angle of incidence greater than critical angle and from denser to rarer medium reflect back to the denser medium, then such phenomena is called total internal reflection or TIR, and there are two necessary conditions. Now these necessary conditions are also mentioned here. First, light should be passing from denser to rarer medium. This is the first condition, and the second condition is that angle of incidence must be greater than the critical angle. So these are the necessary conditions. If these two conditions are existing, only then the phenomena of total internal reflection is possible. Now one more thing is there, we can find the relation between critical angle and refractive index of the media, because these two depends on the combination of medium only. So we can find a relationship between them, that we are going to do next. So the next thing is the relation between critical angle and refractive index. So to find the relation, we have a setup like this, means there is air, water or any other combination of medium. There is a setup in which light is passing from denser to rarer medium, means second medium to first medium. So when we apply Snell's law, angle of incidence will be in denser medium and angle of refraction will be in rarer medium. So from Snell's law, we have sin I upon sin R. Now the ray is going from 2 to 1, not from 1 to 2. So the refractive index that we are finding will be 2 mu 1, means refractive index of 1 with respect to 2. Actually it is the refractive index of second medium, but here medium 1 is behaving like the second medium, because after refraction light is going in the medium 1. So it is 2 mu 1, and we know that it will be equal to the reciprocal of 1 mu 2. So this is the condition that sin I upon sin R is equal to 1 upon 1 mu 2, and if we see the condition of critical angle, we know that if I is equal to IC, means if the angle of incidence is equal to critical angle, then angle of refraction must be 90 degree. अगर refraction का angle is 90 degree, then we call that angle is equal to critical angle. So I am going to put this condition in above equation, and we get sin IC upon sin 90 is equal to 1 upon 1 mu 2. On solving this, we get sin 90 is equal to 1, and by rearranging this or cross multiplying, we get 1 mu 2 is equal to 1 upon sin IC. So this is the relation between the refractive index and critical angle. Now if the rarer medium is air, if this medium is air, then in that case mu 1 is equal to 1 and mu2 let it be the refractive index of the medium with respect to air. So mu2 को हम mu consider कर सकते हैं. Then in that case this 1 mu2 can be written as mu is equal to 1 upon sine I c, because we know that 1 mu2, if 1 mu2 is any medium, this is the relation for the general case. For 1 and 2 can be any medium there, but if the medium 1 is air, then mu1 can be written as 1. Then this relation will become mu is equal to 1 upon sine IC. So this is the required relation between critical angle and the refractive index of the medium. That's all about this video. That's all about the total internal reflection. The two things that we have to keep in mind is object is placed in denser medium, light rays are passing from denser to rarer medium, and if the angle of incidence is more than the critical angle, only then TIR will be possible, otherwise not. Otherwise there will be refraction and the rays will not get reflected back to the same medium. That's all for the video. For further videos, stay tuned and keep studying. Thank you.